Hello, dear students. This is Professor Ramanandan HS, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. We have been continuously interacting on the subject mechatronics with a subject code of 17ME753 for 5th semester of Mechanical Engineering in the college MIT with affiliated university VTU Belgavi. So today we will enter into a new module, module 2, microprocessor and microcontroller. So contents of the presentation or the discussion are microprocessor, I will abbreviate it as MUP, microprocessor, MUP, introduction, architecture. So architecture deals with the structure of or the as a whole component composition of a microprocessor with the help of a pictorial representation, followed by something called a CPU, Central Processing Unit, CPU, Central Processing Unit, and lastly memory, something called as memory. So before entering into topic, so we need to understand these days we are using something called as smart devices. So smart in the sense it is directly related to something called as intelligence. So intelligence is nothing but your ability to acquire and apply knowledge and skills. So I repeat, your ability to acquire and apply knowledge and skills. So I should be how able I am to take the knowledge as well as perform the skills. Not only acquiring, you should be able to apply it also. So understanding and applying, that decides how smart or how intelligent a person is. So similarly, if I say a smart device, say a smartphone or maybe a smart watch or smart systems like smart fan, the modern washing machines, or maybe a smart camera, maybe an engine management system, engine control modules. So everywhere, whenever I use the word something called a smart, so there comes the computing power and the execution speed. So with what way a system can be artificially induced with an intelligence so that it thinks on its own, it carries out the operations on its own and executes the task assigned with the objective it is designed for. So that decides a smart device. For example, a smartphone, so today what we purchase has a microprocessor, because I want you to understand we are already using them in our day-to-day life. So most feasible example is a smartphone, where we usually speak something called as operating system. We say something called as processor speed in terms of gigahertz. We use a term called as hard disk or storage capacity, or maybe RAM, 4 GB RAM, 8 GB RAM. We usually use it. So while buying a smartphone. So all these terminologies, maybe memory 32 GB, 64 GB, nowadays 256 GB of memory, we speak in terms of gigabytes. So all those things we are already using them. So this module gives us a deeper insight of whatever we are using in our day-to-day life, and the darker part is being exposed here. So darker side of whatever we are already utilizing in the form of a smart devices, say a smartphone for example. So similarly, more number of smart devices we are already using in our day-to-day life. So how a microprocessor exists and to what purpose it exists and how it carries out with the help of its component devices, the function. So microprocessor is something similar to your brain. Similar to the brain. It has no independence of existing. It needs a few components around it so that it interacts with the outside world with the help of these peripheral and internal devices, the devices. So microprocessor, I told you it is something like our brain. So since a human body exists with so many things, it exists with organs, organ system, internally if you go, it exists with in terms of tissues, maybe cells, so many glands are there. So similarly, a brain operates with all these things. It exists, it gives the command, it instructs, it takes the data from the sense organs, it manipulates the data, it has its own memory, so that whatever is taught to you right from your school, because we don't know the world. So when we start, when the mother gave the birth, so we started knowing things about the world. So right from there, so right from A for apple, so we know the picture of apple, then we started realizing, apple will be something like the picture. So that picture comes into our mind, because word doesn't display anything. APPLE doesn't display anything. So whenever we imagine that object shape or color or texture, so that is in our memory. So when I say the word apple, your mind will remind you of a fruit apple. So similarly, we have gained so many things from the external world that is stored in our memory. So brain has its own way of tracing the instruction given from the external world. So from the external world, if there is some demand, brain will usually operate with the help of these sense organs, pick up the instruction given, find the whatever memory is being stored in the brain, execute it in a proper way. So with respect to same thing is simulated in a microprocessor. Micro word doesn't, it means that it is a smaller in size. Processor means right from an instruction given till instruction executed. What are all the sequence of operations which comes into picture? So that is called as processing, right from instruction given to instruction executed. So what are all we do? That comprises of this entire module. So microprocessor, so usually can be defined as something like this. It is a multi-purpose. First I will read it, then we will go word by word. It is a multi-purpose, programmable, clock-driven, register-based electronic device that reads binary instruction from memory, accepts binary data as input, and processes data according to those instructions and generate the result as an output. So if you read it as a whole, you may not get the perception in the first stroke of the statement. So go word by word. It is a multi-purpose, micro-purpose. Just imagine the smartphone, because you are using them in our daily life. So smartphone can perform different tasks. It can click a picture, you can easily text someone, you can call someone, you can easily open the Google Sheets with the help of Microsoft Windows operating system. So Excel sheets or Word sheet, you can perform PPTs. So you have a radio there, FM radio, frequency modulation. So many operations. You can edit some picture, So you can edit a song, you can download an MP3, you can get connected to internet, most important thing. So you can get connected to internet with the help of IoT, Internet of Things. So because the mobile phone has the SIM card in it. So subscribers identity module, usually that connects to the network. So a small cloud computing network is formed around the mobile device. So that will usually help in taking the information from the surrounding with the help of radio waves. So that will take the information and fetch it to you on the screen. So there is a display system, so many operations. So it can be used for multi-purpose. So my purpose is served there. So all these are getting operated from the behind device called as microprocessor. That is multi-purpose. Programmable, next word is programmable. What do you mean by a program? So program is understood as simply as instruction. The human being can understand instruction in terms of a language. So if I tell to you pick an object, if I tell to you write something on the board, So these are all the instruction given to you from the instructor, say a faculty. So similarly, machine will be given an instruction from the user. Okay. So how the machine can understand the instruction? So it also has a language called as machine language. So that machine language is the most complicated one. So what do we do as an user or the manufacturer? What he does is, the smartphone manufacturer, he uses a language called as assembly language. So assembly language, you might have done the programs in your pre-university colleges. So we call them as codes, binary codes. So in terms of zeros and ones. So whatever program you type on the external screen, say a display system, with the help of devices like a keyboard and mouse, we give an input as an instructor, we demand something from the system. So that is called as instruction given to the system. That instruction is called as a program. Okay. So it is compiled in the form of codes. Compiled is nothing but it is organized in a proper way. You cannot give in a vague way. Vague instruction cannot be understood by the, similar to human beings. A computer is also similar to human being, because I told you it is nothing but your brain is a microprocessor. That is what is existing in a system. So you have to give an instruction in a proper way with a flow which can be understood by the machine or a smart device. So you give the instruction in the form of codes, compiled codes that can be run, okay, that can run with the help of a software. So usually that is fetched by the microprocessor with the help of addresses, okay, data, memory. Finally it is fetched by the microprocessor and fed to you in the form of, okay, the display. So I repeat, the instruction given to you in the form of codes, binary codes, compiled code in an organized way, is understood as an assembly language which is converted into machine language. Okay. So that is being used as a address. So if you go somewhere, we usually find, okay, we need an address to find someone or to find something or to find an object. So that address, if we go, keep on searching, we, with the help of a data, address is stored in the form of a data. So that data is stored in a place, particular place called as memory, even in our mind also. So if I give an instruction, you will start searching in your brain. So there is a storage device in your brain called as memory. It is nothing but past collected data. Memory is past collected data. So you have a route to reach that data. That route is called as address lines. We call them in microprocessor as lines. So in our body we call them as nerves. Okay, something similar to nerves. We represent it in a non-living microprocessor as a lines. So address lines and data lines will lead us to that memory, trace it out and give it back with the help of same data lines and address lines, okay, to the screen, computer screen or a display screen of a smart device. So that is why we call it as programmable. So okay, you can give an instruction, you can change the instruction, you can write an instruction. So all these are the permitted variables to the user or the manufacturer. Okay, it is permitted in the microprocessor. That is why it is called as programmable. You can change the instruction, you can give the instruction, you can, okay, execute the instruction with the help of a microprocessor. You can feed the information and demand it when and while it is required. That is why it is called as programmable. Clock driven, next important thing. So similar to a human being, we in our body we have something called as a clock, biological clock. So because you wake up early in the morning, so once the sun rises, our body will give the information that you have to woke up from the sleep. You have to wake up from the sleep. So usually we start our daily activities with respect to the daylight. Okay. So it may be eating or regular natural cycles what we perform, eating, sleeping, or maybe working, talking, communicating. Okay. So all these way of expressions of human beings. So everything is time controlled. So again the night, okay, once the daylight goes off, again the night we will go to the sleeping mode. So our entire life, entire solar system is controlled by something called as time. We call it as clock in the system, smartphones or smart devices. Okay, usually we say it as processors. 3 gigahertz, 2 gigahertz. Hertz is nothing but frequency of time, cycles per second. Okay. So every activity, if you go to microprocessor, similar to our human being activity, microprocessor has task to perform. It has to open a page, it has to close an application, it has to enter the data in a MS Word, maybe Microsoft Word or Excel sheet. So it has to calculate something. If you are giving a problem to the system, it has to calculate. In your finite element analysis, we do the calculation part. We give some boundary conditions and we want the data to be simulated and analyzed. So all these varieties of tasks what the computer is performing, okay, all these series of, it needs a series of activity. Okay, whatever single instruction you give to system, it is being split up or fragmented into set of activities which need to be sequenced, okay, one after the other. So that sequence is performed with the help of something called as clock. Okay, it has to be timed one after the other. So that should be driven with the help of something called as clock speed. The more the clock speed, faster the execution of the event. Okay. So that is why we prefer more gigahertz processor mobile phones, because more number of activity can be operated within a less number of time. So that is why it is called as clock driven. So next comes register based. So register is nothing but, if I ask you a question, so what did you have for your lunch or what did you have for your breakfast today? So you easily remember, okay, you have that in your memory. If I go to one day previous to today, yesterday, if I ask the same question, what was your breakfast or lunch you had? So you may find it a bit moderately difficult to remember. If I again go back one day prior to yesterday, that is day before yesterday, and ask you the same question, what did you had for your breakfast and lunch? Tell me quickly for a day before yesterday. So you may start feeling complicated, you may feel to remember. Okay, very difficult to think. Similarly, I may change the example. In your examination, you might have studied a lot of information related to the same subject, maybe mechatronics. You have come to the exam, you are sitting in the exam hall, you are filled with, accumulated with information related to mechatronics. So once the question paper is given to you, you will start all omitting the information whatever you have studied in a hurry-burry, so that you know all the answers to the questions whatever you know, you will start writing. So that is called as register. Okay, registered data. So immediate data which is available to me quickly, so that I can trace it and use it for execution of an instruction. That is called as register. Okay, so that is a easily available information. If I say simply, easily available information. Today's happening you remember, yesterday's happening is a bit complicated. Day before yesterday's happening is registered in your brain, but to trace it out, okay, it is very difficult. Okay. Similarly, complication goes higher and higher when you go collecting the past data and tracing it back. So for that purpose, something called as register is available. Okay, to save it, and whenever the necessity or demand arises, register will give the data easily off to the CPU or microprocessor, okay, to execute an instruction. That is called as register based. So all these words are very important, that is why I have underlined them. So this will give you a very easy, so much of things I have spoken that is easily represented by just writing these terms. If you remember these terms, they are like a formula which will simplify the understanding of a microprocessor. So it is a multi-purpose, programmable, clock-driven, register-based electronic device. Obviously, it works on the charges, electrical charges, because we are using transistors or more number of something called as IC pins, more electronic and semiconductor devices we are using. That is why it is an electronic device that reads a binary instruction. Binary, that means to say it is operating more on two numbers, zeros and ones. We will discuss them in detail later. Those binary instructions are from memory. I have already spoken to you what is a memory. So it is a storage device which will store the data, past data, whatever you have stored. So that data already stored by the manufacturer is called as memory. Accepts binary data as an input. So from the instructor, it accepts the data, processes data according to those instructions. Whatever instruction you have given to resolve, that instruction is taken from the microprocessor and give out and generate result as an output. So this is the entire definition of microprocessor. If you understand it to the deepest level, so it will be subsequently very easy to understand the next set of topics. So what are the technology available to perform all this? So how a microprocessor is made multi-purpose, programmable, clock driven, as well as register based. So all these are being put together with the help of something called as a conducting line should be there. So system should exist as a whole. Connectivity should be there between each and every element. So that is possible by using something called as large scale integration, LSI. I repeat, large scale integration, or VLSI, very large scale integration. That means to say, in large scale integration, for example, you may be using thousands of transistors, because every data is converted into signal, electrical signal, because electrical energy is the most feasible energy to transform and transfer the various types of energy. It can be easily transformed into different types of energy. So that is why we use electricity everywhere in the form of electrical current or electrical charges, ions, that is what we say. So it can be easily transferred from one point to another point. That is the main purpose of converting every data or instruction into electrical signal, something called as electrical signal, or disturbance, electrical charges or ions. These are all synonyms what we use. We will discuss them in detail. So thousands of transistors if you use connected to one another to give electrical signal, to convert the instruction into electrical signal, to convert data into again electrical signal, and finally give out. Both will be happening. Take the input as well as give the output. Everything is being converted into electrical signals. Finally it is given as a data. So here also finally it is understood as a data, but in between you have thousands of transistors. That integration circuit is called as large scale integration. If you use lakhs of transistors, say more the number of transistors, so more number of charges, more data you can handle. So that technology is called as very large scale integration technology. So we will next enter into something called as, with this brief picture, we will enter into 8085, Intel 8085A architecture. So this is just a skeletal diagram of the microprocessor. So what are all the components? We will study them in detail in the module. So right now we will just identify how the as a whole microprocessor exists, but bit by bit, what are the components in a microprocessor? It is usually having 40 pin. 40 pins. Pins are nothing but something like your body external organs, boundary. So with those pins you are interacting with the external as well as internal devices. So pins are the important transacting elements. So it is taking input and some pins are giving output. So that is the purpose of having pins, 40 pin IC package. So just observe here, I will just take you to a small introduction. So this is something called as interrupt controller. This is serial input and output controller. So this line is called as data bus. You can see here this is two-way. So once the instructor gives the instruction, so from you should always go from top down. So from top to down approach. So this part is entire microprocessor part. The instructor has given you the instruction. So instruction is taken from serial input output controller. So it is converted into data here. So it is two-way communication. That is why the double arrow indicates two-way communication. So it is given as well as it is given back. Instruction is given and instruction is also executed and data is given back. So data bus is a line which exists in between the something called as interrupt controller and serial input output controller. So you can see something called as input output switch pins here. Along with that, interrupt is nothing but whenever the instruction is getting executed, the concentration or maybe the immediate instruction that has to be executed by the microprocessor, so that should be handled with a small intervention. You say, for example, So if you need to give an attention to some other activity, you are doing already one activity. If there is one more activity which needs a sudden attention, so someone will interrupt you, someone will call your name, someone may push you, or someone may make a noise, make a sound, say something like this. So that usually give you the attention grasping element, so that you pay attention to the one more activity and again get back to the same activity. So that is called as interrupt. We will discuss it in detail in the upcoming topics. So that is called as interrupt. Right now you should understand the meaning from the word. Okay. So data bus. So this is the line which will usually carries the data. So from where? So you can observe here, there are registers here. Register B, C, D, E, L, H. So many number of registers will be there. So this is a NMOS type of microprocessor, metal oxide semiconducting type of microprocessor. It will have series of registers. I already told you what is a register. Register is a temporary data handling and storing device which will fetch you back very faster the data to the microprocessor. So many registers are there: stack pointer, program counter, incrementer and decrementer. Its duty is to change the order. Incrementer and decrementer is nothing but, so to one after the other, the set of instructions to be executed is usually it should be incremented. Say one after the other activity to perform. So that should be serious, in series they should be pushed forward. So that is handled by incrementer and decrementer. So you can see something called as instruction register. So this is where the data from the instructor is taken here. That is usually fed to decoder and machine cycle encoder. So here the performance of instruction cycle, we call it as instruction cycle, is it fetches the it converts the data or instruction into data and feeds it to timing and control unit. This is the something called as hypothalamus, that is what we call in brain. So that is the core thinking part of the brain, hypothalamus, something like this, timing and control unit. It will be having three stages: control, status and DMA. DMA is nothing but direct memory access. Status. So what is the state right now? So that is being handled by few pins. Control. So usually microprocessor is used as a control system. You have handling with so many activities. If you don't have the control on the activities, it is useless. So there are few pins to control the activity. For example, read cycle. RD is read cycle, write cycle, clock cycle. You have something called as ALE. So this is analog latch enability. So to lock one activity and go to one more activity, come back again to same activity, that is also possible. So all these are nothing but control type of activity. Status activity. What is the input status? What is the output status? So for example, if you are copying a data from one to another, say from pen drive to a hard disk, so a status bar will be usually seen on the computer screen. So that status bar is one form of execution of timing and control unit. So direct memory access is nothing but without the intervention of CPU, directly data is fed to the data bus and in turn to the the user. So without the CPU intervention, direct memory access, that is being fed. So that is called as hold cycle. Hold is nothing but CPU is not involved directly there. Directly memory data is easily fed to you. So that is what we call as memorization. You have memorized the poem, you have memorized some slogans, captions. That is what we usually do, memorize the definitions. So there is no use of thinking there, just recollecting the data. Define something, say state Newton's law, or state Pascal's law, state Bernoulli's principle. You need not put your thinking there, just you are quoting whatever is collected in your brain, you will just recollect it and quote it. That is called as direct memory access. There is no usage of CPU, central processing unit. So CPU comes into picture whenever the thinking is required. There is something called as flag. Flag is nothing but is the instruction executed or not. So that is what we call as flagged or flag off. Flagged on or flag off. So there is something called as accumulator. Accumulator is nothing but a temporary register being provided whether the instruction is executed or not. So all this comprises of something called as a microprocessor with an address and data address buffer. So all these are nothing but storage devices being provided. So this is a brief picture of microprocessor architecture. So coming to the last topic, say CPU is nothing but it is a single chip being built. Single information chip being built is called as a central processing unit or microprocessor. So memory is nothing but storage of binary data, and it takes the form of one or more integrated circuits. So I have already told you, in your life you have gathered so many information. So where are they? If you just bisect your head, you may say I have stored them in my brain, sir. But if you just bisect your brain, can we see any information being there? No. In what way they are existing? Have you ever thought all these things? So you should think about all those. It is stored, your thought or the data is stored in the form of electrical charges, in your brain. Nerves, in the nerves of your brain cells, they have been coded again as a form of electrical charges. Now I am speaking and you are listening. So this activity needs the involvement of the brain. So that is also called as electric field or thoughts being exchanged. I am speaking here with my perception and you are listening with your perception, with your sense organs and hearing to things. So this is also electrical disturbance being set up in the medium or your brain. So similarly, memory is also nothing but it is stored in the form of charges in your brain, electric field. So that is of two types. One is called a semiconductor memory and magnetic memory. For example, semiconductor memory, you have seen pen drives, USB, universal serial bus. So where we use semiconductors there, say silicon oxide or germanium oxide or arsenic materials, where I can ionize the semiconductor and store the information. Magnetic memory is nothing but your DVD, your digital compact disc what we use, video discs what we use. They are usually with the help of a magnetic field and ultraviolet light. You can write or burn the information on the compact disc. That is what we have usually done. These days it may be obsolete, DVDs or CDs. It is available but in minor application. So where you use a magnetic field and ultraviolet light to write or burn the data, that is called as, in the form of magnetic field it is stored. So that is called as magnetic memory. There are different types of memory used in microprocessor. So basically we rely on semiconductor memory here. So first memory is called as random access memory, RAM. You might have seen RAM DDR3 or DDR2, what we usually use in computers. It will be something like your steel scale with so many electronic devices being etched on it or embossed on it or integrated on it. If you look at it, you will not understand anything, but usually they are nothing but transistors being embossed or engraved or etched, or simply integrated is the right word to use. It is being integrated on a chip or the board called as RAM, random access memory. So faster, higher the value of the RAM, faster the execution of the instruction. That is what we already know, while buying the smartphones also. So just to picturize information, random access, the word itself will indicate memory is accessed in a random manner, very quickly you can gather the information. So as well as, if the power goes off, the memory is volatile here, memory is volatile. If there is power supply switched off, the memory will usually go off. You cannot save the memory. So this memory works whenever the power supply is on. You can see here small sketch, the address lines, if you know the address, usually the folders in your drives or website address if you are using internet of things. So it is called as address, website, that is what we use. So if you know the address, data is being shared to the chip, chip select, that is what we have written here, chip being selected, this is a RAM chip. So the user can read and write the information in the RAM. Two permissibility is being provided here. Permittivity is he can read the information with the help of a RAM, and he can also write the information. So in your folders, usually you save some information in the form of Word sheet or maybe Excel sheet. We are saving the data, so that is called as a RAM. Okay. Similarly, something called as read-only memory, ROM. So usually you have been shared with the tutorial compact disc CDs. Okay, that is nothing but ROM. Or in the washing machine or using the smart TVs, you may be provided with a compact disc. So how to use a TV, how to use a washing machine. So that information is stored there. So you are not permitted to write anything, you are just permitted to read the instruction. So such type of manufacturer end memory, okay, where only information is already being written there. You cannot write anything, you can just read the information. That is called as read-only memory. So you have permission only to read the information. That is why you can see address line is unidirectional here. Here it is bidirectional. Data can be read as well as data can be fed. But here only data can be read here in the read-only memory. Okay, similarly you have something called as PROM, programmable read-only memory. So where a permanent program can be written by the user with the help of PROM programmer. Okay, there is something called as a programmer, set of instructions or software. With the help of that you can feed the information to the ROM, that is called as PROM, programmable read-only memory. Next is erasable PROM, erasable programmable read-only memory. With the help of ultraviolet light, so ultraviolet light has a capacity to erase the information being fed on the PROM. So it affect the ionization of the silicon oxide and dissipate the charges. I already told you, data is saved in the form of electrical charges. Once the UV light falls on it, it will usually dissipate the charges. It will change the structure of the ionized data and cancel off or erase off all the data. So such type of PROM is called as erasable PROM or EEPROM. So last one is electrically EEPROM or double EEPROM, electrically erasable programmable read-only memory. So this is nothing but, for the above one EEPROM, you have to remove the unit and expose it to UV light. But here in electrically EEPROM, you need not have to remove the unit. So unit will be as it is there. You can just erase the data and again feed the new set of data to the double EEPROM. That is the advanced read-only memory what exists in a microprocessor. So all this comprises of today's content of presentation. So right from microprocessor introduction, architecture of Intel 8085A, followed by what is a CPU and what do you mean by memory of microprocessor. So hope this presentation reach you appropriately. Thank you.